Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving number of ways to arrive at destination. So the problem states that we are in a city that consists of n intersections numbered from 0 to n2 minus 1 with bidirectional roads between some intersections. These inputs are generated in such a way that we can reach any intersection from any other intersection that there is at most one road between any two intersections. So we will be given an integer n and a 2D integer array called roads, and at every index of roads there will be u, v, and time, and it means that there will be a road between the intersections of vertex u and vertex v, and it will take time minutes to travel there. We want to know in how many ways we can travel from the intersection 0 to intersection n-1 in the shortest amount of time. And after finding that out, we want to return the number of ways that we can arrive there in the shortest amount of time. And we want to modulo the answer by 10 to the 9th power plus 7 because the answer may be large. So if you look at this example, we will return 4 because the shortest way to go from 0 to 6 would be 7 minutes, and there's 4 ways to get there. You can go from 0 to 6 right away, or come to node 4, then node 6, or we can take from node 0 to node 1, then node 3, then node 5, then node 6, or we can do node 0 to node 1 to node 2 to node 5, then node 6. So there are 4 ways, so we return 4. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is we can use a Dijkstra algorithm. So what we will do is we will set up an adjacency list where the keys are the nodes and the values will be a list of tuples where the first element is the cost to get to the second element. So for example, it costs 7 minutes to get to node 6 from node 0, and we will have a min cost array to keep track of the minimum time it takes to get to certain nodes. And don't worry about the min cost at 0 because at 0 it should always be 0, but we initialize it to infinity. And if you want to be very literal about it, I guess you can initialize the first element to 0. But for my sake, I just did infinity times n to make it easier. And we will have a path array to keep track of the number of ways to reach certain nodes. So we will initialize with every node in the beginning at 0 with the exception of node 0 because at node 0, there's one way to get there in the beginning, which because it's already there. And when we get to the end, we will return how many ways it takes to get to the last element, which is n-1. So for this example, it would be node 6. Oh, and if I didn't mention before, the index in the array represents what node that is referring to. So yeah, let's go over this example in Dijkstra real quick. So in the beginning, we will have a min heap, and then we will pop this from the min heap and add all the adjacent nodes to it. And we will continue that until min heap is empty. And I think for the sake of time, I will just play the algorithm on its own, and you guys can keep track by yourself and confirm if it matches this diagram. So yeah, after the min heap is empty, we find out that there's 4 ways to get to node 6 from node 0. So we will return 4, and the time complexity would be O of E log V, where E is the number of edges and V is the number of vertices or nodes, because that's the Dijkstra algorithm. And the space complexity would be O of E plus V, because the adjacency list will depend on the number of edges, and the min cost and path array will depend on the number of vertices or nodes. So now let's get to the coding part. So first we will set up the adjacency list, which we'll call a default dict of list. And then we would set the nodes to each other, so u, v, w in roads. And we will do adjacent of u, append w, which is the cost, and v, which is the other node. And adjacent v dot append w again, and u for the node it's reaching to. And now we need to set up mod, because that is what we need to modulo by, since the answer may be large. And min heap will initialize to 0 of 0. And the min cost will be flow of infinity times n. And path would be 0 times n. And path of 0, we will initialize it to 1. So now we will do the Dijkstra algorithm. So while min heap, we need to get the cost and the node, which we will pop from the min heap, and we will look at all the neighbors. So we'll call it na cost and na in adjacent of node. And if the cost plus the neighbor cost is still less than the min cost at that neighbor, then we can update the min cost array. So it will be cost plus neighbor cost. And we can also update the path, the number of ways it takes to get to that node. And we will also push to the heap. So cost plus neighbor cost and neighbor. Cost and neighbor. And also another case is if the cost plus the neighbor cost is equal to the minimum cost at that neighbor, then we need to update the number of ways it takes to reach that node. So path of neighbor would be equal to the path of neighbor plus the path of node. Path of node. And we will mod by the mod variable in case the number is too large, and then we can return the last element in path. So path of n minus 1. Let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave it down in the comment section, and I hope to see you all again soon.